Okay, good evening everyone. Welcome to the part two of our assembly modeling session. So come straight to your own tab. Basically what you see when you start your modeling session. So you come to assembly. So what we are basically doing is assembling all the parts that we have actually designed. So the first thing you want to do is to insert your parts into the model. So you come to the insert component, and then if the pop-up doesn't show immediately, you can just come to browse. And remember that we saved it into a folder, so you can just easily look for the folder, then just select everything all together so that we don't have to come back and select it. So we pick everything at once and then just click on open. So we'll be dropping them one after the other on our model space. So for some that maybe are not facing the right orientation, you might need to change them. You can change them using this tab here, but this is correct like this. So this is correct. Okay, and we are good to go. Okay, so this are the things, and the and S, the Christian thing. So afterwards, yeah, we are done. So one common mistake that some of us just begin to make is we tend not to okay, let us explain what these symbols mean. This is F here. This one is showing like a minus sign in parentheses. So this is basically telling that it can be moved about. This is an handle now. As you can see, you can move the handle about. So it's telling that it is not how do I call it, constrained. So it means that it is easily moved about. So this is telling us that it has been fixed. So it can't be moved because it's fixed, right? But being fixed sometimes is not what we want. We want to give it a a constraint with other bodies. So you come here, right click on it, and then you can float your model. So this will basically give it the same constraint as the rest. So if this doesn't show in your model, basically tell you that your model, everything is fully constrained. So the first thing you are going to do, since this is the parent body, you are going to constrain this the crankcase. So you come to make. So this is where all the magic happens. So when you want to do this, because what you want to constrain together are not really visible per se, so you have to click on the drop down here. We want to connect the main origin of our drawing to the origin of this model so they can share the same axis and it will be fully constrained. So click on origin and then click on the drop down of the crankcase, the origin of the crankcase. So ensure that the align axis is shown. So you now check it. As you can see, our crankcase has been fully defined. Let us click on OK now. You are going to see what I'm talking about. As you can see, it has been fully constrained, so it cannot be moved about, but it is not fixed. You are not just fixing it at any point. So as you can see it now, it is properly constrained. So next thing we are going to do is to um, constrain other parts of the model. So I think for this pin we need two of this. So to create another one without coming to insert again, you can just double click on what you have already, hold control and drag it out. You automatically have another one. So double click on it, hold control and drag drag it out. I think we need one more, so let's just show it again. So double click on it till everything is selected, hold control and drag it out. So we have another body. So please note that it's going to be very helpful for you when you have multiple things that you want to use that for. Yeah, so let's go to the mate. So what you want to make next, you are going to make this coincident with this hole here. So basically what you are telling the computer is that these two holes, they share the same center point as in the normal sketch tool that we have. So we are making that coincidence. So the next thing that we are going to do, we are going to take us through an advanced feature. So you come to advanced here, advanced. So we are going to use width. So this width is going to allow us find the center point and like make two models align at using the center out, so that you don't have to find the center point for each of them before we can work. So basically now what we're going to do is we're going to select the two faces that is the center is going to align with the center of another two faces. So the first thing I'm going to select is this one. Don't be afraid if your model scatter, you can just use your mouse to bring them back. So you click on these two faces. So on the same body, the two faces that we want it to constrain about, and then for this I want to select this face and this face. So it automatically gives us the model at the center. Yeah, so we check that, and that's basically it. Our model has been, you see that if we check the distance from here to here is also the same distance from here to here. Can confirm that on your own. So that's how we use the width feature. So next thing I'm going to do is to make this also coincident, because this is our piston head. I want to make it coincident to this. Come back to your standard tool, and then we are going to use the coincident constraint. Then no, sorry, the concentric constraint. Yeah. So now we are going to do our coincidence. Okay. So we are putting this face to this face. So we check that. So we are basically done with our, and then we'll come and use one of our pins to know make it coincident to that face. Flip it, because that this is where we want to be, and then we are going to make the center both of them concentric. And that's basically it. We have our um, piston head and the connecting rod connected together. So next thing we want to do is to make this the other end connected to the link. So what we are going to do is make this concentric with this inner circle. So remember, is the back that we want it. As you can see, we have given it the necessary clearance for both sides, so we can flip it using this flip command. But if maybe peradventure yours didn't go well, you can just always come to this. So you flip it if need be. So check that, because our own was correct. Right. So we'll come here, make this face coincident to this face also. So check that. And then we are going to use the bigger pin now. So this is what we need. Make this concentric with this. As you can see, it is like kind of hiding here, so you can just easily drag it out. Then make this face coincident with this face. And basically, we are done with that. We are done with the second half of our model. So the next thing that we're going to be doing now is to complete the model. So let's check this for now and then bring them closer so that as you can see the models are too far. So you can just easily just pick any point and drag it. It's not too difficult. But if you want to follow the reason, you can use the move component here to move them one by one. So you can just basically select and drag. Justify here. Okay. So this is basically what the handle, right? What is what is making our piston head um go up and down. So we are going to select this face, right? Okay, no. What we will do first is to make this because of the clearance on the body. So we are going to make that uh, coincident with this face. So let's go back to the next. Because this is fixed now, it's not moved towards it. Right, so we have to pick what is moving towards that. So come here, select the face, uh, and then select this, make them coincident to one another. But you can see we need to flip it to the other side. Then make the center circle, make it concentric with this, and check that. So we are basically done the first step. The next we are going to do is to make this face. We are going to make it coincident with this face. So remember to flip when your model doesn't give you what you want. So you can flip or use this to check. So what we need is for this to be coincident with this face. So we come here, select this face, and make it coincident with that. So then let us just put this there for now. We don't need it yet. So it's going to be somewhere at the top here. Okay. So this face or this surface here is going to be um, tangential to what we have here. So we are going to select this face, right, and then this face also. So okay, they'll actually be concentric. So they'll have same center circle for both of them. So they'll be concentric. So we have that, and then we check it. So another thing we want to do is to make this face parallel to this face also. So select it, ensure that your parallel constraint is selected, and then you have that. So check it. So check it. So we are done with that part. So now so we want this part of the circle to have the same center as this one too. So we are going to make it concentric and check that. So now we are going to make this face coincident to the face that we have created beforehand. So they'll be parallel to each other, and then we check it. So and that's it. Now we are going to use this concentric to this check. So we are going to make this face coincident to this face, and then we have that, right? So Okay, and that's basically it. So we are actually done with our um. So why all this? We still have all this is because of the motion study that I'm going to be showing us now, because that's the interesting part of this. So let's make this space transparent and then can basically see how our model has connected, and then we are able to move it. So the next thing that we'll be doing would be to create a motion study that's using this motion. It will be able to uh, it will be able to do this automatically by itself. Right? So I'm going to be creating a motion study. So to create a motion study, basically I'm going to come to motion study here, and then using with the aid of these tools, we are going to create the motion study of our model. So let me make this, let me make it a solid work so you can, yeah, our model is correct now. All right. So the first thing to do is is to put we have a motor constraint here. So what we want to move about, what's the driving force? So we have this component which is going to be moving in that direction. So let's say 100 RPM is too large. So let's say 30 RPM. So basically, and here we are going to set the, let me do that before we continue. We actually will not want to exceed 10 seconds. So let's keep it at 10 seconds. So yeah, so we're going to so put our motor, select the space that we want to drive, and let's say 20 RPM. So we're going to set it. So this is the rotary motion. So we are going to set it for 10 seconds. This one, own solution to run for 10 seconds. So you can play it to visualize and see the rotating at the back. So that's the 10 seconds has been completed. So let's take our line back. So we want the camera to, hey, I want, yeah, okay. So we want our visual to be changing as is moving about. So we can, uh, okay, at this point, set, so we use our place key, uh, to the next key, and then here, let's unlock, then maybe at the final, make this transparent, and then place in that, this one, So our motion study. Yeah, that's nice. So we'll save the file. You can, yeah, we'll just save the animation video to wherever we want to save, and then let's say crank shaft animation. Save that. So, and that's basically it, the end of our assembly tutorial. So the motion study, I believe, is an add-on. So yeah, thank you for watching. I really hope you have a great night.